The complete microservice roadmap, from foundation to management. Introduction. Navigating the microservice ecosystem. Welcome to the comprehensive microservice roadmap, a visual guide that maps out the entire ecosystem of technologies, patterns, and tools needed to build, deploy, and manage modern microservice architectures. This isn't just a technology list, it's a strategic roadmap that shows how different components work together to create scalable, resilient, distributed systems. As we journey from the foundational container layer at the bottom to API management at the top, we'll explore how each layer builds upon the previous one, creating a robust architecture capable of handling enterprise-scale applications. Layer 1. Container Foundation, the building blocks. At the very foundation of our microservice architecture lies containerization, the technology that makes modern microservices possible. Container technologies. Docker stands as the dominant containerization platform, providing lightweight, portable environments for applications. Containers solve the "it works on my machine" problem by packaging applications with all their dependencies. LCC, Linux Containers, represents the underlying Linux container technology that Docker builds upon, offering system-level virtualization with minimal overhead. Why containers matter? Containers provide several critical advantages for microservices. Consistency. Applications run identically across development, testing, and production. Isolation. Services are isolated from each other and the host system. Resource efficiency. Much lighter than virtual machines. Scalability. Easy to spin up or down based on demand. Layer 2. Security. Protecting the distributed architecture. Security in microservices presents unique challenges because you're now protecting multiple services communicating over networks rather than a single monolithic application. Security technologies. JWT enables secure information transmission between services through digitally signed tokens that can contain user identity and authorization claims. OAuth provides authorization framework allowing services to access resources on behalf of users without exposing credentials. TLS encrypts communication between services, ensuring data privacy and integrity across the network. Node.js appears here, likely representing secure server-side development platforms that implement these security protocols. Security considerations. Microservice security requires service-to-service authentication, ensuring services can verify each other's identity. API security, protecting service endpoints from unauthorized access, data encryption, both in transit and at rest, security monitoring and readiness, detecting and responding to security threats across distributed systems. Layer 3. Languages, the development foundation. The language layer showcases the polyglot nature of microservices. Different services can be built using different programming languages based on their specific requirements. Programming languages. Java remains a popular choice for enterprise microservices due to its maturity, ecosystem, and performance characteristics. JavaScript/Node.js excels in building lightweight, event-driven microservices, particularly for APIs and real-time applications. Python is favored for data processing services, machine learning workloads, and rapid prototyping. Go offers excellent performance and concurrency support, making it ideal for high-throughput services. Polyglot architecture benefits. Right tool for the job. Choose languages optimized for specific tasks. Team expertise. Teams can work with languages they know best. Performance optimization. Different languages excel in different scenarios. Innovation. Ability to adopt new languages for specific use cases. Layer 4. Message broker. Asynchronous communication. Message brokers enable asynchronous communication between microservices, providing reliability and scalability for distributed systems. Message broker technologies. Apache Kafka leads the distributed streaming platform space, handling high-throughput, fault-tolerant messaging with excellent durability and ordering guarantees. RabbitMQ provides reliable message queuing with support for multiple messaging patterns and excellent routing capabilities. Apache Pulsar offers cloud-native messaging with multi-tenancy and geo-replication capabilities. Communication patterns. Message brokers enable several important patterns. Publish-subscribe. Services publish events that multiple consumers can process. Request-response. Asynchronous request-response patterns. Event sourcing. Storing all changes as a sequence of events rather than current state. Saga patterns. Managing distributed transactions across services. Layer 5. Monitoring and alerting. Observability. Monitoring distributed systems presents unique challenges. You need visibility across multiple services, networks, and infrastructure components. Monitoring technologies. Prometheus provides powerful metric collection and storage with a flexible query language for analyzing system performance. Grafana creates beautiful interactive dashboards for visualizing metrics and logs from multiple data sources. Jaeger offers distributed tracing capabilities, helping you understand request flows across services. ELK Stack, Elasticsearch, Logstash, and Kibana provide centralized logging and log analysis capabilities. Observability pillars. Effective microservice monitoring requires metrics, logs, traces, alerts, automated notifications when systems deviate from normal behavior. Layer 6. Container orchestration, managing at scale. Container orchestration platforms manage the deployment, scaling, and operation of containerized applications across clusters of machines. Orchestration platforms. Kubernetes dominates the container orchestration space, providing sophisticated capabilities for deploying, scaling, and managing containerized applications. Docker Swarm offers simple orchestration capabilities built into Docker, suitable for smaller deployments. Apache Mesos provides more general-purpose cluster management capabilities that can run both containers and other workloads. Orchestration capabilities. Modern orchestration platforms provide service discovery, automatic discovery and registration of services, load balancing, distributing traffic across service instances, autoscaling, automatically adjusting capacity based on demand, rolling updates, deploying new versions without downtime, health checks, monitoring and replacing unhealthy instances. Layer 7. Distributed tracing, understanding request flows. Distributed tracing becomes essential when requests span multiple services. You need to understand the complete request journey. Tracing technologies. OpenTelemetry provides vendor-neutral standards for collecting telemetry data from distributed systems. Zipkin offers distributed tracing system that helps gather timing data for troubleshooting latency problems. AWS X-Ray provides distributed tracing for AWS-based applications with minimal configuration. Tracing benefits. Distributed tracing enables performance analysis, identifying bottlenecks across service boundaries, error debugging, understanding failure cascades in distributed systems, dependency mapping, visualizing service relationships and communications, SLA monitoring, tracking request latencies and success rates. Layer 8. Database, data management strategies. Database management in microservices often follows the database per service pattern, where each service owns its data. Database technologies. PostgreSQL provides robust relational database capabilities with excellent ACID compliance and advanced features. MongoDB offers document-based NoSQL storage suitable for flexible, schemaless data models. Redis serves as both a cache and data store for high-performance use cases. MySQL remains popular for relational data with good performance characteristics. Data management patterns. Database per service. Each service owns its data and database. Shared databases. Multiple services share databases, generally discouraged. Event sourcing. Storing all changes as events rather than current state. CQRS. Separating read and write data models. Layer 9. Cloud provider. Infrastructure foundation. Cloud providers offer the underlying infrastructure and managed services that support microservice architectures. Major cloud providers. AWS, Amazon Web Services, leads with comprehensive service offerings and mature ecosystem. Google Cloud Platform GCP excels in container services, AI Ensure, and data analytics. Microsoft Azure provides strong enterprise integration and hybrid cloud capabilities. Memcache appears here representing caching services available across cloud providers. Cloud benefits for microservices. Managed services, databases, message queues, and other infrastructure as managed services. Autoscaling, infrastructure that scales with demand. Global distribution, deploy services across multiple regions. Pay-as-you-go, cost model that aligns with actual usage. Layer 10. Caching, performance optimization. Caching becomes critical in microservices to reduce latency and database load across distributed services. Caching technologies. Redis serves as a high-performance in-memory cache with support for various data structures. Memcached provides simple, high-performance distributed caching. Hazelcast offers in-memory computing with distributed caching capabilities. Caching strategies. Service-level caching. Each service manages its own cache. Shared caching. Multiple services share cache instances. CDN caching. Content delivery networks for static assets. Database query caching. Caching frequently executed queries. Layer 11.
Load balancer, traffic distribution. Load balancers distribute incoming requests across multiple service instances, ensuring optimal resource utilization and high availability. Load balancing technologies. NGINX provides high-performance HTTP load balancing with advanced routing capabilities. HA Proxy offers reliable, high-performance load balancing with excellent health checking. Traefik specializes in modern container-aware load balancing with automatic service discovery. Kong combines load balancing with API gateway functionality. Load balancing strategies. Round robin, distribute requests sequentially across instances. Least connections, route to instance with fewest active connections. IP hash, route based on client IP for session affinity. Health check based, only route to healthy instances. Layer 12, application gateway, unified entry point. Application gateways provide a single entry point for client applications, handling cross-cutting